Hello, everybody. Blue Thunder here, back at LeetCode Contest Corner. It is week 359, and it is also the final week of LeetCode Contest Corner for the summer of 2023. I know, it's all you viewers out there, it's kind of sad. This is the end for this year. Um, but I got classes are coming up in a week or two, and I, you know, I can't, um, I don't want to have to worry about doing this and doing my homework. Um, I'm a simple man. I need my free time. Maybe too much. I don't know, but yeah, that's how it's got to be. Got to focus on the schoolwork. Um, so yep, we'll go through this week, and then I'll tell you my future plans for the year. And yeah, all right, so let's get started with this week. As always, congratulations to Hank 55663 for getting first place. Good job, good job. Um, and then also, as you can see, I got two done this week. That's right, this week is a big week. We got two. um, I didn't think I was gonna be able to get the second one, which would have been embarrassing because the first one was so easy. So, um, yeah, let's get into it. As always, I will read out the description and then I will hopefully describe the description afterwards to make it more easily understandable if anyone doesn't get it right away. And then I'll go through my code and show you how I solved the problem. So let's get right into it. Check if a string is an acronym of words. Given an array of strings words and a string. Okay, let me just restart. Given an array of strings words and a string s, determine if s is an acronym of words. Is an acronym of words, right? Okay. The string S is considered an acronym of words if it can be formed by concatenating the first character of each string in words in order. For example, AB can be formed from apple, banana, but can't be formed from bear, aardvark. Return true if S is an acronym of words and false otherwise. Okay, so as all right, so what does this mean? Is I think it's isn't too hard. So you're given two goes here. You're given two inputs. You got an array of words of strings, right? um and then you're also given a string s. So you need to see if you take the first letter of each word in words, you put them into its own string. So this would be Alice A, Bob B, and Charlie C. So that would give us a string ABC, and we need to check if that string is the same as the string they give us, in which case this one is the same, so it would be true. And then here we got A an, and then A apple, so that would be AA. AA does not equal A, so it's false. And then here we got N never, G gonna, G give, U up, O on, YU, that does equal NGGUOY, so it's true. Um, so yeah, it's really simple. I think you probably take 5 seconds or 10 seconds to think of I don't know why it was specific about that. Takes 10 seconds to uh think of how you would program this, and then um just like quickly how you'd program this, and then guess what? It's probably the same way I did it. All right, I'll give you the 10 seconds. Yep. All right. All right. Let's get into my code. All right. Okay. So, all right. So we got it's a boolean, so we're gonna have to return true or false. We got words and string. The list. And of course, I give it a list, make it a bit harder, I guess. I guess you know what I honestly I appreciate it. Makes me work a little bit. I mean, we're not using too much of like it's not really racking our brains with using the list stuff with what we had to do, but it's just a little extra layer, I guess. So we got that. Okay, then we got the string X. This is where we will store the acronym that we get from words, all the different words we get. So that's what X is. Okay. Then we start a for loop that will go through each. That will go through those sides. So we go through each. Um, bleh, go through each word. Yep. And then okay. So then we got X equals X plus. Okay. Words dot get I. That that gets the so I is a number that gets the word of that's at this position, I's position from words, and it says dot substring 0 to 1. So this is um the substring starts at 0, which is the beginning, the first letter, and it goes to 1, and because the last what it goes to is where sorry, you got a word like dog. It'll 0 to 1 means it just means D. So think of 0 is where the starting point starts, and the first number was the pointer starts, and then the second number is where it ends. So the first one, yeah, they both start before the letter, so it starts before D, and but we want it to end after D, so we end it at 0, at O, sorry. So then it gets us this substring D. So yeah, so this gets us the first letter, and then we put each of the first letters into X. Um, And then we got some cool optimization right here. So you might think like if you're a newbie, you might think, okay, I have to check if. So you think, okay, let's put this if X, or we got the acronym of the words. If X dot equals S, if that's true, then we return true, else we return false. You don't got to do this because this right here is just this is a boolean right here. So x dot equals s. If x and s are the same, this is true. This is a this is a method, so it'll return true, and so this is just true, and so it'll return true to this. Otherwise, if it doesn't equal x, it'll be false. So it'll return false, and then this will return false. So yeah, we don't need an if or an else or anything like that because that's just an extra step. So just thought I'd point that out. Thought I'd make it a little give the give a little easy pointer to some people. You don't always want to do this. It might be like more easy to read the code if you keep the if else statement in, but for small things like this, then yeah, you should probably do it. So, or you can do it. It's faster, faster to type out at least. So yes, that is Akron. All right. So as you can see, we got that true. So this one, um, I don't know. Okay, it doesn't show it here. We'll go here. If we check my thing, as you see for this one, I did have a couple of bugs. I had a couple of incorrect attempts. This one was tricky, a bit of a warning. It might be hard to follow um how my stuff works. I don't know how well I'm gonna follow it. Gonna be honest. I kind of like cobbled some stuff together, and I really hope that uh, I can describe it well enough. Um, but yeah, but sometimes I heard this before, and I think it's a good idea. Honestly, cobbling stuff together. If you're writing code, if you're practicing with stuff, if you're just practicing, cobble stuff together. See, just do something. If you're coding, do something, man. It doesn't matter if it's not perfect. It's okay. You just cobble stuff together, fix the stuff afterwards. Who cares? It's your own personal stuff. You can always make it better. Um, the point is to practice. try new stuff. Um, yeah, so just you know what? Don't worry about it, about not being. I promise you, a lot of people and their personal codes, it is not as pretty as their professional codes. Um, anyways, just trying to give some uplifting advice there, I guess. So let's get into this one. Determine the minimum sum of a k avoiding array. You are given two integers, n and k. An array of distinct positive integers is called k avoiding array if there does not exist any pair of distinct elements that sum to k. Return the minimum possible sum of a k avoiding array of length n. Whoa, that is something, right? Okay. So, okay. Um yeah, okay. So I think I'll just go to the code just so I have something to type out here. So okay, so here, see, I was testing this out earlier. So you got this, um, so okay, you got minimum sum. So the four is how big the array is, and the five is the k. That's what you're avoid. That's what it wants you to avoid. What does that mean? It means in the array you want none of the pairs of numbers to add up to five. Like there should be no pair of numbers in the array that add up to five. Um, So you might think, oh, well, an easy way to do that, and then also all okay, then also another. There's a couple of caveats. The first one, the first caveats is that all the numbers have to be distinct, right? So you think, oh, okay, they can't add up to five. Well, easy peasy. It has to be a length of four, so it would be five, six, seven, eight. That's easy. You know, they're all distinct. None of them add up to five. Well, there you go. That's an easy array. Well, you also want it to be um, the smallest array. The small, like you want if you add up all the numbers in the array, you want that number to be as small as you can possibly get it. So, like for example, for this one, well, you could definitely still do 4, 5, 6, 7. You know that none of those add up to five. So, okay, so then you need to find out how do I get that to be the smallest possible. Um, So, so that's our two biggest things. They have to be distinct, and the thing has to be small. And then of course, then yeah, and then the biggest thing, nothing can add up to five. No pairs can add up to five. So in case you're curious, like so, like one, two, three, four. This array wouldn't work because four and one add up to five, as well as three and two add up to five. So this is a bad scenario. You don't want this array won't work because there's at least one pair that add up to five. And yeah, it can be any pair, does they don't have to be next to each other or anything. So okay, so we're gonna get into how I did it. I don't know if it's probably not the only way, but it's kinda is how I did it. Um I don't think I mentioned did I mention it? Uh it the thing over here it probably says it somewhere. Oh yeah. Okay. Distinct positive integers. That's also important. I forget. There's another caveat. So it has to be positive integers. So yeah. If it was if you could do negative, obviously, then you'd want try to whatever the smallest int could be. You'd want to use that, but because negatives and such. Um, but what was I gonna say? Uh, yeah, but you can't because negatives don't work. But then this also means that you can't use zero because zero isn't positive or negative. So, and it just says only use positive. So you can't use zero. So if you're ever worrying about, okay, well, can't we use zero at some point? No, we can't. Um, like they could have worded it so it could include zero as a problem. I bet. I wonder how much easier or harder that would have been. Um, it might have. Uh, definitely would have been interesting. I don't know, but the fact is, it doesn't include zero. So yeah. So what's interesting about this, because none of the numbers equal zero, that means you're probably, unless like you have something like this, like okay, maybe instead of five it was, I don't know, 50, 45, then yeah, this could have worked, but like you might find that we'll include the number five a lot, because then because five can be included because it'll definitely be added by something. I don't know. That's just something I thought of. I don't know, little interesting bit. Um, so yeah, okay. So let's just get into the code. I'm just trying to prepare you. So yeah, just a quick reminder. So we got the array has to be at least four long, and none of the pairs can add up to five. And each number has to be distinct, and no zeros or negatives. Okay. So let's start here. So we got um, first thing I do. So I create an array list, um, and then I create. So this is a for loop, and it starts at one, and it goes till it's to list out length. So and then I add for then I have for each part I equal it to I. Okay, well, what are you talking about? So just all this to say, it loops through and it creates the smallest array of distinct numbers, right? So this is if we start with four, um, then it'll go one, two, three, four. Discord, shut up. Hold on, let me mute this. Okay. I don't know if you heard that. Discord was being annoying. Okay. So, anyways, back to this. So yeah, so this would create an array of one, two, three, four. If it was five, it'd go one, two, three, four, five. If it was seven, it'd go one, two, three, four, five, six, seven. Blah blah blah. So that's what this part does. Okay, simple, simple, right there. Okay, so then okay, is where it this is where it gets interesting. Okay, so we got this while reset is true. We'll see what that means in a minute. Um so yeah, what so just know, so we start the while and then we reset to false. Okay, so we're gonna want to watch out, where do I set it to true, where do we start looping again, right? Because if it stayed false the entire time, we only go through this once. You just want to keep an eye out where reset equals true. This loop, this while loop, basically the purpose of this is to ensure that all the numbers are still distinct and that none of the pairs add up to five, or any add up to five or any other number, whatever k. None of the numbers add up to k. Okay, so then we're going through. Oh boy. Then we're going through all the pairs. Okay, so we start with the for loop I that'll keep track of the first number in the pair. And then okay, then we got another boolean we good. uh just put a pin in that for now. We got that. And then we got another for loop j, so that'll keep track of the second number in the pair. So then so then we'll start with like one, and then we'll go one and two, one and three, one and four, and we'll have two, two and three, two and four, and then three and four, and then so that's what these are about. Okay, so and so then right, and then little note like, oh, what about when I is four? Well, yeah, I'll be four, and then J will be five, but then J will already be greater than list.length, so then it won't even run that, so we'll be done. Okay, okay, so got this for so now we got all the pairs. We got the pair we're working with. This is system printout because I was having issues, so we can ignore that. Okay, if we good. So that is saying if so far there hasn't been anything that up to five. Okay, so if we're good, all right, then we check. Okay, does this current pair that we're looking at, does that equal? I keep saying five. Does that equal to k? Does that equal k? Um, if it does, then we ain't good. We ain't good. We said we good to false. And then I could have, so then we're gonna start doing this. We're gonna start and we're gonna ignore this. Again, this is just I'm gonna get rid of it. That's just another thing because I was confused. Um so we set we good and equals to false. Um and then so this is what we're gonna start. We're gonna now it's like okay, so this so we got so we're at like it's like okay, we're at the pair um 2 and 3, right? That equals 5. It's like, oh man. And I think that would be the first. Well, no, okay, the first one would be 1 and 4. Okay, so we're like, oh shoot, we need to make sure that all the numbers we're gonna need to start adding the numbers to be bigger. That's what I did. I made them bigger so that they don't equal 5 anymore. Um, because of course when we start, we can't make anything smaller because they're all as small as they can be. Because it's like if we make 3 equal to 2, but then they're not distinct anymore. So, so okay, so in this case, 1 and 4 equals 5. So we're like, oh, we're not good anymore. So we change 4. We increase what we're going to do, and what I'll explain through the code. We're going to increase 5. Then okay. Then we go through all the rest of the numbers, and there are no rest of the numbers. Okay. Then we keep going. Then we're on the 2, and we're going through. Oh, hey, 2 and 3 that equals 5. Okay, so we increase so what we're going to do, we're going to increase 3 is going to become 4, and then 5 is going to become 6. So just because why do we do that? Because if we were um let's pretend let's pretend the 1 didn't exist because it could have been like this. We increased the 3, we made that 4. Oh, then the 4s are the same. So we have to increase everything behind it. Now this one, yeah, so this is why this part is ensuring that all the numbers stay distinct and that nothing equals 5. That's an important point. Now, you might already be thinking, okay, that's not the smallest anymore, right? Because um, you could have definitely still had 5, right? 1, 2, 4, 5, because 5, yeah. And then we got the 4 again. And so, yeah, we'll have to change this to 5 and 6. But yeah, but what we're doing, right? So we got 1, 2, and then 4, 5, and then we're going to increase it again. So it's going to be 5 and 6. Sorry. Okay. So sorry. Okay. 1, 2, 3, 4. We increase the 4 to 5. Then we increase the 3 to 4 and the 5 to 6. And that's good for now, I think. It gets weird. Okay. I'm just trying to. Right. No, then there. Sorry. Right. Then we see, oh man, the 1 and the 4 we'll see how we'll get to that. We will get to that. You might be we're gonna see. Okay, so then we're gonna make 4 will become 5, and the 6 will become 7. So that's so, all right. So then we'll get here. You might notice that's not the smallest, right? We could make that 7 back into a 6, I believe. Yeah, because yeah. So we could have that be 6, but this part isn't gonna do that. We're gonna do that later. I'm just trying to keep y'all on the big picture kind of here. Um, so yeah, all right. So, and then you might have noticed another problem. So yeah, okay. So that's what we're doing here. So we get here, we set we good to false and reset equal to true. All right. So um, this is important. This one's important. This one's also important. So now, because okay, let's go back here. List I and list J. Let's say they didn't equal to K, and it was still we good. Then I keep testing through all the pairs until we have a problem. Because if um, there's nothing else in this for loop, right? If we good, right? Because yeah, if say if we good, and then there's nothing else, then we go back to the for loop, right? So it's just testing to make sure that each pair is good. So then if we're no longer good, we found a problem. So now we go down here. We have this, which we ignore. This. So then yeah. So then it just increases the list. So then it goes to um, all the J's for the I that we're testing. So now, the last part is bigger, right? So then we go back. So um, we're done with this for loop. Then we're also, which means we're also done with this other for. Mm, yeah, no, no. Okay, so then we move on. Right. Okay, so we go to the next first number, and we check we good. We set that back to true, and then we check if this second number has any other issues. Um, but as you saw earlier when we were doing this, so let's go back. We go one, two, three, four. Okay, so what we basically just did. Okay, so we did one. We got I is one, J is two. That's fine. Three and one. That's fine. Four and one. Hey, that equals five. So we increase four to five. Okay, and then that's the end of J for this one, coincidentally. So that's it for J. So then we go to here. I is two, J is three. Oh, hey, that equals five. So three becomes four, and five becomes six. So then, okay, and then we check. So then we're, yeah, so then that's that. Then I is one, and then as you can see, so then, so yeah, I is four, J is six. Those don't add up to five. So that's the end of that. So then, as you can see, we got four and one still here, but then we're done with this for loop. So that's why we got while reset. So we had reset equals to true. So we're gonna start again. We're gonna go through it again. Um, so then it's okay. So I is one, J is two. That's fine. I is one, J is four. Hey, that's not right. So we make four, five, and six, seven. And then, yeah, then we go through all of them and they should be good for this particular number. So yeah, so this, I believe, should be the result of this while loop because it'll go through and then after it fixes that, the reset will be set to true again. But then once it goes through it, it's not going to change anything, and then it'll be good. It'll be okay. It was not nothing reset was never set back to true. So then we're done with this while loop. Okay. I hope you guys could maybe follow that. I know this is a little tricky. I hope I'm doing an okay job. So yeah, so now, okay, so if we just left it at that, like I did, and I got one of my bugs, um, we don't have the minimum number yet. We still, because remember, we could make the seven smaller. That's now we want to make it as small as possible. My friend is playing a game. Okay. Um, all right. So we go down here. Um, anyways, okay. So we go down here. Um, all right. We got we got the sorry, my head's out of it. Okay, we got now we're gonna this for loop is gonna make it smaller. So we got another for loop for I and then for J. So we're going through the pairs again. Okay. Um now now we have a while true loop. This will loop forever unless we have a break, which I do right here as you can see. So let's get to that. So this is going to check for each number. We're going to see if we can make it smaller. Um, and so yeah, so we have x. We say, hey, okay, x, the second number. We're going to see if we can make that one smaller and see if that breaks anything. So we have x equals j list j minus one. Okay, then we check. Okay, is x It needs to be greater and equal to k or equal to k, and that is um, because as long as x is greater than or equal to k, then we don't really care about what number it is. It can be small as we want, because if it is like I said earlier, if it's equal to k, then anything we add will just make it bigger and it'll be fine. And we can't have zero, so it'll be fine. And then obviously anything greater, and then you add more, it'll still be greater. So yeah, so it'll never equal k. So that's to make sure, basically to make sure the sum doesn't equal k. I guess thinking about it for this part at least, if zero was involved, the only thing we'd have to fix is we'd make sure it's greater than k. Now, because of this, I it worked. The LeetCode accepted it, so presumably they had all the test conditions and it was good. But I like maybe there's some way we could algorithmically go through the smaller numbers, the numbers that are smaller than k, and make them even smaller, and then maybe they could still be fine to make them smaller at this part. But I don't know how. And so, but that's all to say there might, for some specific set of numbers, there might be a smaller number we could have gotten than with this method. But I'm not sure. Like I said, this is where I'm cobbling stuff together. This whole for loop was basically like, okay, can I make it smaller and will it accept it? And turns out it did. So, okay. So that's this first part. First, we're like saying, okay, let's just deal with stuff greater than k. Um, if we can do that, that would be great. All right. So that's that. And okay, so that's that first part. Then we need to make sure, okay, um, now does x equal, we're making it smaller, right? Does it, we need to make sure it doesn't equal the number before it. So if we, let's just say we gotta know, this is our array, like, and we're dealing with 4. If we try to make 4 to 3, this would no longer work because 3 does equal 3, so we don't want that. So we'll leave it at 4. Yeah. So yeah, so that's what also we'll make sure. And then it won't equal the number after it, because the if you notice with how I've done everything, the array will always be ordered from smallest to biggest. So if we're just making it smaller, there's no issue with the numbers on the right. So yeah, so we just need to worry about the numbers on the left or earlier in the array. So as long as it's bigger than k or equal to k, and it's not the same number as the number before it, we're like, okay, then we can have that number. So we'll make the actual number in list at j, we'll make that the small one smaller. So then that's the end of this if statement. So then we go around back to while true, and then okay, can we make it smaller? And we keep going, and then once we find, at some point it's going to be the same size um, as sorry, it'll be the same size. What am I trying to say? The numbers will all be close together, is what I'm saying. Right? You might have a, like, let's say we have a gap like 3, 4, um, 8, 9, right? And it adds up to 5 or whatever. So eventually it'll be back to 5, 6. Well, that's what's going to happen. And that pauses there because I just realized I really didn't need to go through the pairs. I could have just gone through each number in the list. Um, I'm pretty sure. Hmm. Um, yeah, so this part is kind of redundant now that I think about it. I'm pretty sure. Yeah, I don't see any eyes in here. So it's kind of seems redundant. So oops. Okay. So hey, learning new things. See, I guess it can be a good thing to go through your code. You might find stuff where you're like, oh, I was unnecessarily longer. Like sometimes you do stuff longer because it's easier to understand, or sometimes you do stuff like this where you're like, why did I make it longer? I didn't need to do that. This could have been just a for loop and gone through each number, and we could check if we could make each number smaller. That's all we could have had would have had to do. Um, but you know, live and learn. Okay, it's good to go through code. Moral of the story. Okay, so yeah, so this goes through all the numbers and makes it as small as can be. And um, yeah. Okay, so then, this is the easy part. Then we create sum, and then we got this for loop goes through all the numbers of the array and adds them together. This is a system print. We don't need that. And so yeah, it adds them together, and then we return the sum. That's it. Simple as pie. This last part is at least. But yeah, this whole thing is pretty tricky. Um, Try to go through it again. Okay, so we start with the array. We create the array with the numbers um 1 through n minus one. Or no, it'd just be 1 through n, 1 to n each number because it starts at 1. And then we got Boolean reset, and then while reset is true, reset equals false. Then we go through each of the pairs and we check if they equal to if they equal k, and if they do equal k, then we increase that number out that part, and then all the numbers after it, and then we keep doing that until we make sure there are no pairs that equal to add to k. Then we go to here and we go through each of the numbers and we can see if we can make them any smaller. At least we make sure all the numbers bigger than k, bigger or equal to k, see if we can make them smaller. Um, and if we can, we do. Um, and then we add then we should have the smallest array. So then we add up all the numbers in the array, and that is what we return. That is the answer they're looking for. Okay, so that's minimum sum. Um, yeah. So that was this one. We got this true. See, I want to see. Okay. All right. So we'd make j. Let's make this equal to 0, and then can we just do boop boop, and then doop doop, and we'll submit it. It accepts it. Yeah, there we go. We didn't need that extra for loop. I think at one point, like when I was creating this important if statement, I had like making sure that the numbers didn't add up to k. But then I'm like, wait, if the numbers are bigger than or equal to k, then they'll never add up to k. So I got rid of that part, and so because of that, I don't need I anymore. So yeah, all right, cool beans, cool. We found that. Like I said, LeetCode accepts it. So assuming they had a very rigorous thing, I don't know if there's any way we could. Um, no, apparently not. uh, oh, okay. All right, yeah. Oh, well, yeah. See, there's a lot of test cases, so it should. It seems like it would work. I wish I could look at them all, but yeah. Uh, it passed all of them, so that seems pretty good. That seems like a pretty good like I did it, but you know, I don't know. I did my best. This is like a cobbling code. Um, yeah, this one was tricky. It was tricky to like keep your head wrapped around it, right? Kind of hard to keep track of. So, so that was that one. That was this week's LeetCode contest. Um, yeah. I hope you had a good time. I hope you enjoyed watching. I hope maybe you learned something. Maybe you learned how much of an idiot I am. Like, oh, I could have done that a million times better. Um, yeah, if you did, you know what? Throw it in the comments. Tell me how you did it. I'm happy to see how other people did it. All right. So, like I said at the beginning, this is the last League Code contest of summer 2023. Um, uh, I had some ideas for the semester to maybe make videos about my coding stuff, any coding stuff I do through the semester. However, um, I don't exactly. I know I only have math classes this first semester, my fall semester. One of them is like math as it relates to computer science or whatever. So I don't know. Maybe there's some like somehow coding is involved. I kind of doubt it though. It's probably just math that's super related to what people in computer science use is what I'm guessing. I don't remember the exact names of the classes. So all that to say is I don't think there's I'm gonna have anything to show for this semester, any videos, any coding videos at least. Like I said, I'm gonna focus on my schoolwork and then winter semester, which is like goes until end of April, so it's not just winter. Um, I have I'm fairly I don't remember. I signed up for my classes and then I'm like I want to forget about this. I don't like school. Um, I'm fairly certain I have some programming classes, so I don't know. Maybe I can do something with that. I don't want to get in trouble for like putting up all the answers or whatever for a homework, but also I would really love to like show you guys stuff and like maybe like I have a visual stuff of what I've learned. But I don't know. We'll have to see. But like I said, if I do that, it's gonna happen. It'll have to be in 2024, with the winter semester. So yeah, there's nothing gonna be happening anytime soon with programming. Of course, um, there's still other there's like gaming videos. I might post something. I don't know. I might if you made it this far. I might have something planned already for a certain game that's coming out. A little something something. I guess you'll have to wait and see. I think it'll definitely come out in the fall, but I don't exactly know when because I'm waiting to see when something is announced. So I guess we will see about that. But yeah, other than that, anything else, I don't have any big plans. I might do something. We'll see how much free time I have um for other types of videos. Yeah. Uh and then in the so yeah, I got that planned and then not much else planned. I don't know. We'll see. Like I say, sorry, I'm repeating myself. If I have more free time, I might post stuff. I don't like to overburden myself with stuff. Like I said, I like my free time. And then in winter, like I said, there might be coding videos, might be programming videos of some sort. We'll see. And then probably, yeah, I don't have any plans for winter, so no gaming videos then. Um, because next winter semester I have I only have to go in 2 days a week. Oh, that sounds nice, and it is nice. I'll admit. But I have to be there like all day, and it sucks. I got like bunch of hours where I have to stay at school, but I can't do anything there. I don't have any classes, which I don't enjoy, but it is what it is. Like I said, at least it's only 2 days a week. Um, so I'm definitely gonna want to enjoy my days off. um, yeah. So um, other than that, that'll be my plan then. Then presumably, then I don't tend to do summer classes because I usually need a break by that at that point, and seeing as how I have a schedule that I can't stand for the winter semester, I'm probably going to again take another summer break. So because of that, I League Code contest should return um probably beginning of May, maybe very end of April, but I would just um probably like the first like it'll probably be the first or second Saturday I have of my um of summer vacay, right? So that's what I'm so it'll yeah, that's when I'm gonna start again with League Code contest. And hopefully by then I will have improved is what I'm saying. I hope I'll have improved. I am definitely I should be taking programming classes in the winter. So hopefully I'll get a little better. Maybe I'll be able to get a few more specific problems done. Um, yeah, so that's what I'm looking forward this school year, this year. I'm a little nervous for some stuff, but take it one day at a time. And you can do it. That's what you got to do. All right. So this is the last time for this year. I hope you guys had a good summer. I hope you guys have a good year, and I'll see you guys next time. Goodbye.